So in this video we are going to derive the shape function and stiffness matrix for a beam element. I am going to separate into two videos. The first part is to derive the shape function. The second part, from the shape function arriving the stiffness matrix. So as in the case of bar element, the shape function can be arrived by assuming a polynomial function of the required degree. Why I am telling the required degree means how much of unknowns are there in the given problem should be considered. So you have to add the constants which is equal to the number of unknowns so that the result can be a exact result. So for the beam element, you have to understand the different terminologies used. So we assume the rotation of the beam element is like this. The rotation at x equal to 0. Here it is x equal to 0. Here it is x equal to L. The rotation at x equal to 0 is pi 1. At x equal to L is equal to pi 2. In the same way, the nodal force at x equal to 0 is F1y and the displacement at x equal to 0 is referred as d1y. Similarly, at node 2, the nodal force is F2y, the displacement is d2y. The y displacement is referred with v. If you have the displacement in x direction, we normally refer as u. As in the case of bar element, you assume the displacement function as u equal to z0 plus c1x plus c2x squared. Here the displacement is a vertical displacement. So your assumed equation should be in the form of v. So this is the beam element. Here the number of unknowns are rotation at two nodes as well as the displacement at two nodes. 4 unknowns are there. So we can include 4 number of terms in the polynomial function. So I am going to write as a1x cubed plus a2x square plus a3x plus a4. So totally 4 constants are there. So the boundary condition at x equal to 0. So you should know the different boundary conditions. At x equal to 0, v of 0 equal to d1y, because at x equal to 0 the displacement is referred as d1y. At x equal to 0, the slope, that is dv by dx, at x equal to 0 referred as pi 1. Similarly, at x equal to L, the displacement v of L is referred as d2y. At x equal to L, the slope dv by dx of L is referred as pi 2. So use this as the boundary condition. So we have to find out the value of a1 to a4. a1 to a4. So I am substituting the first boundary condition. X equal to 0, v of 0 equal to d1 of y. So putting v of x is d1y and putting all x term as 0, finally we come with the constant a4 is d1y. So we get one of the results, one of the value for the constant, that is for a4. The next, dv by dx dv by dx. So you differentiate the terms. 3a1x square plus 2a2x plus a3. So dv by dx of 0, when x equal to 0, we get only a3 constant. So it is directly related with the slope at x equal to 0. So we also get the value of a3. So we get the value of a4 and a3. The next item to be find is a1 and a2. So for that, substitute x equal to L in v of x. So v of L is equal to a1 L cube plus a2 L square plus a3 L plus a4. Next, for dv by dx, substitute x equal to L. So 3a1 L square plus 2a2 L plus a3. So we already know the displacement at x equal to L is d2y. The rotation at x equal to L is pi 2. So keeping the equation, we can substitute the value of a3 and a4. So the dv by dx at x equal to L referred as pi 2, which is 3a1 L square plus 2a2 L plus the a3 value is pi 1. The a3 value is pi 1. So you keep this is equation number 4. And substitute the value of a4 here. A4 value is d1y. So v of L is equal to d2y, which is a1 L cube plus a2 L square plus a3 L plus d1 of y. So which is 5. Equation 5. So I can redefine with this, that is the slope here it is pi 1, here it is pi 2. So by rewriting this, pi 2 minus pi 1, which is equal to 3a1 L square plus 2a2 L. So keep this is equation number 6. And from this equation, d2y equal to a1 L cube plus a2 L square plus a3 L plus d1y. So we have the value of a3 here. So d2y minus d1y, which is a1 L cube plus a2 L square plus pi 1 L. So you bring all the constants on the same side. So d2y minus d1y minus pi 1 L, which is equal to a1 L cube plus a2 L square. So the equation 6 in the form of L square L, here we have L cube and L square. So you divide this equation by L. So d2y minus d1y minus pi 1 L by L, which is equal to a1 L square plus a2 L. So you keep this is equation number 7. This is equation number 6. This is 7. So we are going to solve this two equation. Either you can multiply with this 7 by 3 You have 3a1 L square and here 3a1 L square common. You can cancel each other to get the value of a2. So that's what we are going to do. So multiply the equation number 7 with 3. So 3 by L d2y minus d1y minus pi 1L, which is equal to 3a1L square plus 3a2L. The next equation, pi 2 minus pi 1, that is sixth equation, which is equal to 3a1L square plus 2a2L. So we just subtract the equation, cancel the a1 term. So 3 by L d2y minus d1y, and separating this term, minus 3 by L pi 1L, so you can cancel the L term, minus pi 2, because here it is minus, so minus pi 2 and plus pi 1. So these are the terms on left side of this equation. Right side we have 3a2 minus 2a2, so it is a2L. It is a2L. So we are going to find out the a2 value. So divided by L, it is 3 by L square d2y minus d1y minus 3 pi 1 and plus pi 1. So minus 2 pi 1 by L minus pi 2 by L, which is equal to a2. So I am going to rearrange the term in terms of d1 dy. So you can put minus 3 by L square d1y minus d2y minus 1 by L, taking outside pi 2 plus 2 pi 1, which is equal to a2. So we got the value of a2 here. We got the value of a2 here. So substituting the equation a2, substituting the value of a2 in the previous equation, to get the value of a1, so we keep this is 7. We can substitute in the value of the equation 7. So next page. So pi 2 equal to, so I am going to write in the next page, pi 2. So equation 5 is I am writing pi 2 is equal to 3a1 L square plus 2a2L plus a3. Pi 2 equal to 3a1 L square plus 2a2L plus a3. So here 3a1 L square plus 2L, we got the value of a2 minus 3 by L square d1y minus d2y minus 1 by L 2 pi 1 plus pi 2 plus a3. a3 value is, we know it is pi 1. So pi 2 is equal to 3a1 L square. So if you multiply with this and cancel L and L square, it is minus 6 by L d1y minus d2y minus, if you multiply the 2L inside, with this component 1 by L, it is minus 2 into 2 pi 1 plus pi 2 plus pi 1. So pi 2 minus pi 1, pi 2 minus pi 1 is 3a1 L square minus 6 by L d1y minus d2y. So if you multiply with this 2 inside, it is minus 4 pi 1 minus 4 pi 1 minus 2 pi 2. So I am bringing all the pi 1 terms to the left side. Plus 4 pi 1 minus pi 1 is 3 plus 3 pi 1 plus 3 pi 2, which is 3a1 L square minus 6 pi L d1y minus d2y. So we see 3 is a common factor for the above step. So divided by 3 will give pi 1 plus pi 2, which is a1 L square minus 2 by L d1y minus d2y. So a1 L square is equal to pi 1 plus pi 2. Bring this side plus 2 by L d1y minus d2y. a1 is pi 1 plus pi 2 by L square plus 2 by L cube. So I am bringing this L square to the right side. So it is multiplied with L square with the L term. 2 by L cube d1y minus d2y. So this is the value of the constant a1. So we are getting all the constant values, and we can substitute with the basic assumed function, that is a1 x cube plus a2 x square plus a3x plus a4. a3x plus a4. So a1 value v of x is 2 by L cube d1y minus d2y plus pi 1 plus pi 2 by L square. So this is one term should be multiplied with the coefficient x cube plus a2 minus 3 by L square d1y minus d2y minus 1 by L 2 pi 1 plus pi 2. The whole term should be multiplied with the coefficient x square. Plus a3 value is pi 1, so pi 1x. a4 value is d1y. So keep this is the complete equation. So you can define with the equation number 1, complete equation of the problem. So now our idea is to separate the term in terms of the shape function n1 d1y, n2 pi 1 and n3 d2y, n4 pi 2, because a beam member is having the member coordinate of displacement as 1, displacement d1y, member coordinate 2 is the slope of that particular node 1, and 3 is the displacement of node 2, 4 is the slope at node 2. So we have to assemble in such a way that, so v of x is equal to, I am going to split all the terms. V of x is equal to 2 by L cube d1y minus 2 by L cube d2y plus 1 by L square pi 1 plus 1 by L square pi 2 into x cube. And the next term plus minus 3 by L square d1y, minus into minus is plus, so plus 3 by L square d2y and minus 2 pi 1 by L minus 2 pi 2 by L multiplied with the x square. plus x cube, x is multiplied with the a3. So pi 1x plus d1y. So I am going to separate the term for d1y initially. I am taking 1 by L cube as common because all the terms contain 1 by L cube maximum. So I am taking 1 by L cube as common. So it is, see the cofactor of d1y. So we are taking L cube outside. So 2 into multiply with x cube. So 2x cube minus where another d1y is here. So it is 1 by L cube we have taken outside, but here it is 1 by L square only. So we should multiply it with the L at the top. So minus 3L into x square, minus 3L into x square plus here d1y is there. So we have to multiply with the L cube blindly because the cofactor is 1. So multiplied with the L cube. So d1y. So it is completed. Next one, 1 by L cube. We are going to assemble pi 1 because it should be in the order d1y, pi 1, d2y and pi 2. So concentrate on the pi 1 terms. So x cube by L cube, L square is there. X cube by L square is there. So x cube multiply with L because we should convert into L cube. So x cube multiply with L minus the second pi 1 term here is minus 2 pi 1 L into x square. We need L cube here. So we should multiply with the L square. So minus 2 L square x square. Here pi 1 x only is available. So we need to multiply with the L cube. So plus L cube into x because we have taken L cube outside. Some of the term is not having L cube in the denominator. So we have to convert into the equivalent factor. So d2y. Okay, I think I have concentrated on d1y or pi 1. xl cube minus 2 x cube L. So it is, I think it is pi 1 term. So very, we should be very clear what we are writing. So it is pi 1 term. Next I am going to write the d2y term. So what is the cofactor of each d2y? So I am taking 1 by L cube as a common. So concentrate on d2y. So it is minus 2 L cube x cube. Already is L cube is there. So no worry. It is minus 2 x cube is the cofactor. The second term 3 by L square into x square is there. So we have to multiply with the L. 3L x square. So with the d2. So there is no another term present. So only two terms for d2y. So d2y plus I am going to write for pi 2 value. So pi 2, concentrate on the pi 2 term. It is x cube by L square. We need L cube in the denominator. So x cube L. The next term it is minus 2 by L x square. So we have to convert into L cube. So multiply with 2 L square x square. Multiplied with the 2 L square x square by 2. Okay, I think it is finished. Minus 2 x square L square. So again I am going to verify for the pi 2 term. Pi 2 is here x cube by L square. So x cube L. The second term is minus 2 pi 2 by L x square. So minus 2x square L square, minus 2x square L square. Okay, finally we can arrange. Finally we can arrange the shape functions. Phi 2 minus 2, phi 1 plus phi 2. So we have to check whether it is minus 2 L square or minus L square by 2. Minus L square by 2. We put minus L square by 2. I think in previous step it is plus pi 2 L square, 2 pi 1 plus pi 2, the second term. Here I am separating pi 1 by L square and pi 2 by L square. In the second term I am writing minus 2 pi 1 by L and minus 1 pi 2 by L. So here I made some mistake. It is minus pi 2 by L. There is no 2 multiply with this. So if you consider pi 2 minus x square L square. So there is no 2 term here. Now it is correct. Minus L square x square. So next page I am going to write in the form of shape function. The shape function is the interpolation function between the local displacement to the global displacement. The global displacement here we can represent with the d because it combines d1y, pi 1, or d2y and pi 2. So I am writing v of x is equal to n1, n2, n3, n4. It is a scalar matrix. Here vector d1y, pi 1, d2y, pi 2 is the vector quantity. So we get v of x is equal to n1 d1y plus n2 pi 1 plus n3 d2y plus n4 pi 2, where n1 is 1 by L cube. We can get it from the previous conclusions. 2x cube minus 3x square L plus L cube. n2 is 1 by L cube x cube L minus 2x square L square plus xl cube. n3 is 1 by L cube minus 2x cube plus 3x square L, and n4 is 1 by L cube x cube L minus x square L square. So all of you kindly take these notes and practice this derivation. So this is not the completion of this derivation. Further step is to find out the stiffness matrix. Any given problem, the derivation is asked to find out either the shape function or the stiffness matrix function, or either they can ask both the stiffness as well as shape function. So we have to familiar with these steps. We have to derive this equation completely. So in the next video we are going to derive the stiffness function for the beam element. Any stiffness matrices does not change according to the problem. So we have to remember the stiffness matrix also.